everyone. In this video we will discuss about some proofs of trigonometry related to unit circle which will help us finding the values of t ratios for different angles. Okay, so let us start. If you have not subscribed my channel, please do subscribe because it is totally free. It gives me motivation to do work. Now we have considered a unit circle. Obviously the radius is 1 and the points are A, B, C, D which cut the axes. So the coordinate of these points will be 1, 0, 0, 1, minus 1, 0 and 0, minus 1. Now we consider a point P on the circle such that distance of this point P from x-axis, okay, is equal to this OM. So this is perpendicular PM on this x-axis, and we choose this point P in such a way that this OM and PM are equal. So what we do, we assume that PM is equal to OM. Okay, it means these two values are equal. So let us say x, they are x, and this is what radius of this unit circle. So obviously this value is 1. So OP is always 1. So in this triangle we can see, if we apply Pythagoras theorem, then p square plus p square is equal to h square. Now let us put the values. X square plus x square give us 1. So 2x square is equal to 1. So x square is equal to 1 upon 2, or x is equal to 1 upon root 2 plus and minus. Remember guys, जब भी यहाँ पर power 2 होगी, always plus and minus sign will come. Okay, so out of this plus and minus, now just focus. What is x? X is the distance between OM, between PM. Okay, so this distance cannot be negative. That's why we are taking x as positive 1 upon root 2. Okay, this distance cannot be negative. Now we can see one more thing, that in this triangle this angle is 90 degree and these two sides are equal. We know a property of geometry that if in a triangle two sides are equal, then angles opposite to these two sides, it means this angle as well as this angle, they are also equal. So we can say these angles as theta. Now we know by angle sum property that theta plus 90 degree is equal to how much? 180 degree. So let us simplify. 2 theta is equal to 90, subtract from this, so this is 90, it means theta is equal to 45 degree. So we get this value, that this angle will be of 45 degree. Okay, so theta will be 45 degree, or we can say pi by 4, because we know the relation that pi radian is equal to 180 degree. Pi radian is equal to 180 degree, so pi by 4 will be 180 by 4, that is 45 degree. Now we have to find the values of t ratios for this particular angle. Okay, let us see how can we find. So in this triangle PMO, let us redraw this. P, M and O. This is 1 and this is x, and the value of x is 1 by root 2. Here also it is 1 by root 2. Now in this triangle what we observe, that if we find sine theta, this is theta, this is also theta. Okay, and the angle is already given to us, this is pi by 4. So sine pi by 4 is how much? This is perpendicular upon hypotenuse. Perpendicular is 1 by root 2 and hypotenuse is 1. So we can say the value of sine 45 degree is 1 upon root 2. Similarly, if we find cos pi by 4, this is base upon h, and base is also 1 upon root 2. Hypotenuse is 1, so this value is also 1 by root 2. Okay, so what is tan pi by 4? Tan pi by 4 is perpendicular upon base. Perpendicular is 1 upon root 2, base is also 1 upon root 2. So divide the same value, we get 1. So in this way we can find the values of other t ratios also. So you have seen that how can we find the value of a particular angle with the help of unit circle. Okay, unit circle help us in finding the values of t ratios as well as for many proofs. So now we find the value of t ratios for angle pi by 3, that is 60 degree. So for this we take point P in such a way that these two sides are equal. Okay, it means we take the point in such a way that OP is equal to PA, and we know OP is radius and it is equal to 1, so this is also 1. Fine. OA also radius of the circle, so OA is also equal to 1. So this is the condition when we talk about this particular angle. Fine. So this triangle becomes equilateral triangle. Each angle of equilateral triangle is pi by 3, that is 60 degree. Okay, so this angle is pi by 3. Okay, it is also pi by 3. Now we draw perpendicular. Okay, let us call this point M. This is perpendicular. Now in this triangle POM, okay, we are discussing now in triangle POM. This angle is 90, it is pi by 3. This value is 1. Now what we know about this OA? OA is also 1. But what is this OM? When we draw perpendicular in an equilateral triangle from any vertex, this perpendicular actually divides the opposite side into two equal halves. We know this is a theorem, okay, and we can prove it by congruency also. By congruency of these two triangles, we can prove this result also. So this OA is actually 1 and this OM will be equal to half. Okay, this is also half. So OM we have come to know it is half. Okay, now in this triangle POM, 1 we have known this side and this side we have known, and PM, this is only unknown side. So let us find the value of this PM. So by Pythagoras theorem, PM square plus OM square, this is OP square. So PM whole square will be equal to OP, this is 1, minus OM, OM is half. So 1 minus half square means 1 minus 1 upon 4, that is 3 by 4. So PM will be equal to root 3 by 2. So this value is root 3 by 2. Now we talk about t ratios. So first we talk about sine pi upon 3. Okay, this is perpendicular upon hypotenuse. What is perpendicular for this? The side opposite to this angle is perpendicular. Fine. So this is root 3 by 2. Hypotenuse is 1. So the value is also root 3 by 2. Now cos pi upon 3. This is base upon hypotenuse. Base is 1 upon 2. Hypotenuse is 1. So the value is also half. Then we talk about tan pi upon 3. This is perpendicular upon base. Perpendicular is root 3 by 2 and base is 1 upon 2. When we divide, 2 cancel, so it becomes root 3. Okay. When we need to find values of other t ratios, we can just reciprocate these values. Okay, we can take reciprocals. So cosec pi by 3 will become 2 by root 3, sec pi by 3 will become 2, and cot pi by 3 will become 1 upon root 3. Okay, in this way we can find the values of t ratios for particular angle pi by 3. If we need to find the values of pi by 6, then also we require this triangle. This triangle will only help us in finding the value of pi upon 6. Okay, so let us see how. Here we have seen that two angles of a triangle are known to us. Pi upon 3, that is 60, and this is 90. So 60 degree plus 90 degree, suppose this angle is x, so plus x is equal to 180. So when we simplify, this is 150, So x is 30 degree only. 30 means pi upon 6. So this value is pi upon 6. Now in the same triangle, we have known all the sides, we know about all the angles, but here we require this particular angle only. So what will happen when we take this angle? The perpendicular will be this side, okay, and base will be this side, okay. And when we talk about this angle, this is base and this will be perpendicular, okay. This all you know already. So let us find quickly sine pi by 6. This is perpendicular upon hypotenuse. What is perpendicular for this? Pi upon 6, this value 1 upon 2. Hypotenuse is 1, so the value is 1 upon 2. Cos pi by 6, this is base upon hypotenuse. Base is this value. Hypotenuse is 1, so the value is root 3 by 2. Now tan pi by 6, this is perpendicular upon base. Perpendicular is 1 upon 2. Base is root 3 by 2. Divide. So we get 1 upon root 3. Okay, for other t ratios, we can take reciprocals of these values. I will discuss the next proofs of trigonometry in my next video. If you have not subscribed, do subscribe my channel and share it to others. Thank you for watching.